can flip the model. So if we operate M star 3, on our video, if we flip the model on the left diagonal, our resulting element is number 3. So this is our table. For our number 4, flip between horizontal axis and left diagonal. So this is our horizontal axis. This is our horizontal axis. So this is our left diagonal, and based on the definition, on the moments of number 4, it is between the horizontal axis and left diagonal. So number 4 defines flip between horizontal axis and left diagonal. So it is the red broken line. So when we operate M as our initial point, 2, 4, which defines a flip between horizontal axis and left diagonal, resulting elements will be number 4. So this is our table. And for number 5, it's defined as flip from the horizontal axis, which is represents the red broken line. So when we operate M to 5, it is equal to, so let's see the video. So M, our initial point, and we will flip it. So our resulting element is 5. So this is our table. Next one, for 6. 6 is defined as flip between horizontal axis and right diagonal. So it is between the horizontal axis and the right diagonal. So this is the broken line represents the flipping between horizontal axis and right diagonal. So M star 6 is equal to, let's see in the video. So M, we will flip between horizontal axis and right diagonal. So our resulting element is number 6. So this is our table. So now for our number 7 is defined as flip from the right diagonal. So this is our model, and the red broken line represent the right diagonal. So when we operate M star 7, it is equal to, based on our video, when M is our initial position and we flip from the right diagonal, our resulting element would be number 7. So this is our group table. So for the last one, we have 8. That is defined as flip between vertical axis and right diagonal. This is our model. It is the vertical axis, and this is the right diagonal. And based on the definition, it is between the vertical axis and right diagonal. So the red broken line represents our movement. So when we operate M star 8, based on our video, if we have M as the initial position, and when we flip between vertical axis and right diagonal, our resulting element is number 8. So this is our group. So this is our table. So next one, if we continue do the operation, the binary operation, we have this table of elements. So now let us verify if this table is a group. In order to determine if our geometric model forms a group structure, we must ensure that it meets the following requirements. So what are the following requirements that needs to be satisfied? So first one is close. It must be close. So meaning to say, in the table, all the resulting elements is in the set or in the set of the number of the letters and the numbers, which are MARCOSQT and 1, 2, 3, 4, 5, 6, 7, 8. And we must satisfy the associativity. and it must have identity element. And last one, it must have inverse element for all. So now, let us first verify if it is close. So based on our table, we can check that all the resulting elements or the outputs in our table is in the set of the numbers and the letters we have in our geometric model. So, therefore, it is close. The next one, to determine if it is associative, we must rotate the table 180 degrees. So when we rotate the table 180 degrees, this is the table after we rotate it in 180 degrees. So next one, we need to rearrange the columns of the table. So we need to interchange all or alternate column 2 to column 8, column 3, column 7, column 4 to column 6, column 9 to column 15, column 10 to column 14, and this column 11 to column 13. So after we rearrange the table, we have this table, which is equal or it is the same in our previous table. So the resulting is MARCOSQT 1, 2, 3, 4, 5, 6, 7, 8. So this is the resulting or the output of the binary operation, and it is the same. You can verify by posting the video. So since it is disclosed and based on our verification a while ago, it is the same as the previous table, which is it means as it is associative. So next one, let us verify if it has a identity element. So based on our table and by using our general formula, which is x star e is equal to x, and e is our identity element, if we use this table, m star m is equal to m, our identity element here is m. So, and star a is not equal to itself, but a star p is equal to m. So here a, if we operate a star m, it is equal to itself, which is a. So based on that, if we operate r star m, it is also equal to itself. And based on our general formula, if we operate letter x in uh in element, it must be equal to itself. And based on our group table, our identity element is m. So this is it. M star m is equal to m, and a star m is equal to a, and r star m is equal to r, c star m is equal to c, o star m is equal to 0, o star m is equal to o, and s star m is equal to s, q star m is equal to q, and t star m is equal to t. It is also the same in our numbers, which is 1, 2, 3, 4, 5, 6, 7, 8. And by concluding, our identity element is M. So therefore, our table is also uh, it is also closed. Again, it is closed, it is associative, and by verification, we did earlier, our table has a identity element, which is our identity element is letter M. The next one, to determine if this table has a has a inverse element for all. For each element, we use this general formula: x star x prime or x inverse is equal to E. Again, to prove or to verify or to find inverse, we use this general formula. So m star m is equal to m. Since m is it is our identity element, and by using this formula, we can see that m element m is also its inverse, the inverse of itself. So m star m is equal to m. So A star T is equal to M. So the inverse of T, the inverse of A, I mean, is T. So here is the pattern or the quick way to find the inverse element of an element. So first one, let's look in the first row, which is M. So uh look for the identity element, which is M. So the inverse element of it is in the column, appears in the top. So it is M and A. Let's look for the identity element, which is M, and the column in the upper portion is T. So T is the inverse element of A. So R, we look for the letter M, and M, the upper portion, which is Q. So this is the way how to find the inverse element in the table. So as what you can see, each element has a inverse element. So M, the inverse of M is M. A, the inverse of A is T. The inverse of R is Q. The inverse of C is S. The inverse of O is O itself. So the inverse of S is C. The inverse of Q is R. The inverse of T is A. The inverse of 1 is itself. Also for number 2, 3, 4, 5, 6, 7, and 8. Their inverses is themselves. So again, in our table here, it is closed. It is associative. It has an identity element, which is letter M. And based on our verification we did earlier, it has inverse element for. So our group table and our geometric model, which is Marcos spider web, since it is satisfies all the requirement, therefore it is a group. So that's all for my geometric model. Thank you for listening and watching.